Hi, and welcome to your first actual flipped lesson. What we're going to be looking at today is particularly factoring, a lot of different things. We'll look at foiling as well, but we'll also talk about factoring. The first type that you might remember is GCF. That's the distribution method where you multiply everything that's inside of it. So in our first example, we would bring all of these things into our parentheses, and we want to multiply all this stuff. We multiply our numbers, so 4 and -7 make -28. And we got x cubed and a y. Then we've got -7 times -3, that's going to be +21. X doesn't have anybody, so we'll keep it an x squared, but y does, so we'll make it a y to the 4. We can do this in reverse. We want to look for what is the biggest thing that we can divide both of these numbers by. So 35 and 14 can both be divided by 7. We also notice that they both have an x in them, so just an x. We also notice that they both have a y in them, so we can take out a y. But both of them have 3 y's that we can take out, so we want to take out all 3 of those. So we end up with, let's see, 35 divided by 7. X divided by x is just 1, so it's gone. Y cubed divided by y cubed is 1, so it's gone. 14 divided by 7, that's -2. X squared divided by x, that's an x. And the final y cubed divided by y cubed is 1. So really it's nothing, so we just leave it alone. You can double check that by distributing the 7xy cubed back into the parentheses, and you should get back with what you started with. Next, we've got difference of squares. So this is a shortcut for foiling. So rather than doing all of these things, but first, outside, inside, last, you can multiply the first 2 numbers together, you get 4. Multiply the last 2 numbers together, so x and x is x squared, and then just slap a negative in the middle. You can reverse this process as well. You see those 2 things are being squared, you could break it up into 2 sets of parentheses and square root everything. So 121, square root that, that's 11. Square root z squared, that's just z. You give one of them a positive and one of them a negative. You might have noticed that this isn't matching the pairing up here. It doesn't matter what order you do the plus or minus. You just need to make sure that one of them gets a plus, one of them gets a minus. Next, if we're looking at perfect squares, this is a shortcut that you can use in order to multiply things together a little bit faster. I'm going to talk about foiling in just a second, but this is just a shortcut. Rather than doing first, outside, inside, last, you can square the first thing. So, I forgot to square it. So 2x squared gets us 4x squared. Square the 2, square the 4. Then you square the thing on the end, that's 9. And then in the middle, you multiply these 2 together. So you do 2x times 3, that's 6x, times another 2, according to this formula we've got up top. So that's plus 12x plus 9. You'll notice that this thing is not equal to 4x squared plus 9. There's some common mistakes that happen in pre-calculus, and this is by far one of the biggest ones. Well, not by far. It's probably second. There is one that's worse than this one. But it's really easy to distribute that squared in there, but it doesn't work like that. You do need to use this perfect squares trick, or write it 2 times and then FOIL your result. But hey, we've been talking so much about foiling, we should probably do one, right? So let's do that one in this next example. Foil represents, if you don't remember, firsts, outsides, insides, and then lasts. So we want to multiply our first 2 things together. X and 2x gets us 2x squared. Then you want to multiply your outside numbers. So that's the x and the -5, so minus 5x. Then your 2 inside numbers, which is the -8 and the 2x, which gets us -16x. And finally, your last numbers, -8 and -5, which is 40, positive 40. This is sometimes called, I like to call it the moon method, because it kind of makes like a little crescent moon thing. Isn't that cute? Aww. Lastly, you're going to combine all your like terms, so you get 2x squared minus 21x plus 40. I combined that negative 5x and the negative 16x. I'm going to do a couple more examples. We got to talk about unfoiling. So when you're unfoiling, my trick that I remember is I want to multiply to this number on the end. So I'm going to be trying to multiply to that 21 or multiply to that 40. Then you need to do whatever this sign is to get to the middle. So what multiplies to be 40 and adds to be 13. So 4 and 10, that multiplies to be 40. But 4 plus 10 doesn't get 13, so I don't want that. However, 5 and 8, that multiplies to be 40, and it adds to be 13. So those are the two numbers I want to do, 5 and 8. They need to be multiplied to be positive, so they have to have the same sign, and they have to add to be negative 13. So if I did positive 5 and positive 8, it would be positive 13. I want negative 13, so I'm going to subtract. In the next one, we've got a GCF again, so I'm going to take that out first. So I got an x, got x squared plus 4x minus 21. Oh, there's a little doo-doo-doo on my computer. I changed a bunch of files. I don't remember doing that. So I want something that multiplies to be 21 and subtracts to be 4 this time. So I think, well, 1 and 21, those subtract to be 20. So that's no good. 3 and 7 multiply to be 21. And 7 minus 3, that'll get us 4. Sweet. So I should do that. So let's do 7 and 3. I want them to add together to be positive 4. So I want 7 to be bigger and 3 to be smaller. And there is our factored thing. Whoop, whoop. All right, final example, I believe, of the day, is this one. This is the box method. The box method is for these pain in the butt ones where we have a leading coefficient, where there's a number on that x squared. That just gives us a tough time. So what you need to do with these ones is, well, in my opinion, is to use what's called the box method. To do the box method, you draw a box. I know, wild, right? Boop, 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 boop. You put the leading term here and the last term there. Then you multiply the first and the last numbers. So the 6 times the 15. Because we got to figure out what goes in those other two boxes. 6 times 15 is 60 plus 30, so that's 90. And we do that same trick that we were doing before. What multiplies to be 90, and then add or subtract, because we got a plus there, I want to add to be 19. You might spot that pretty quickly as 9 and 10. 9 times 10 is 90, and 9 plus 10 gets us 19. So I want to do a 9. I'm going to give them both x's and a 10. Since they got to be negative 19, I want to make both of them negative. After you have done this, all you need to do to finish the factor is do GCFs. Do GCF this way, this way, this way, and this way. So the GCF of, for example, if we go, sorry, I'm waving, but you can't see it. If we go across here and find our GCF, it is 3x between 6x squared and negative 9x. If we go this way and we look between negative 10 and 15, we've got a 5. Now, if there's a negative on the edge, which there is in this case, see there's a negative right there, grab that as well. If we go this way, our GCF is 2x. And if we go this way, it is 3. Based on this, we can complete our factor as 2x plus 3 and 3x minus 5. And that's it. There's other ways that you can do these ones, like guess and check, There's the Morse method. I know this other thing called math magic. There's all kinds of ways to deal with these things. Mostly they're a pain. The box method I've resulted to as the simplest one. And that's it for our notes today. What you need to do now is you just watch the notes from this video lecture. If you'd like to see additional examples, maybe I did one and you're like, oh, I'd really like to see another one. I don't have a video recording of it, but in the PDF version of the notes, I do more examples than I do on here. So if you'd like to see more, you can go there. What you must do before our class next time is complete this check for understanding. I'm going to be giving you a collection of problems, and you just need to determine what method of factoring you should use in order to factor it. You don't even have to factor anything on it. You just have to determine what the best method of factoring is. That's it for our video. Thanks for watching. I hope you enjoyed it, and I will see you in class soon. Okay, bye.